we were only able to actually talk about what's the other one? Uh, resultant force. So resultant force is when we take two or three forces, or even more, that's acting on one object, and then we combine it. Basically, we combine it to find out what is the remaining or resultant force, right? So resolution of force is kind of like the opposite of resultant force. So resolution of forces is the process of resolving a force into two components. So what that means is that in resolution of force, you have one force, okay, in one direction, and you're going to divide it into two components or two parts. So why would you want to do that? Well, you might want to do that because you want to see what is the downward force doing and what is the horizontal force doing. So for example, here's a picture, and you can, this is all from your textbooks. Most of the pictures I just copied from your textbooks. So here's a picture of a boy. He's pulling what looks like his brother, and he's pulling in a diagonal direction, so not vertical or horizontal, but looks like to be around maybe 30 degrees. And so what we want to do is to divide that force into a vertical component and a horizontal component. So basically we're going to take a force that's like this and divide it into two parts. No sound? Is it just for Colisi? Or okay, so Davy can hear. How about the rest of you? Okay, Henry can hear. Okay. Others, others can hear. Try, restart. Exit, then enter again. Okay, let's wait for Kolisi to come back. So if the rest of you can hear, then the problem's probably on her end. Yeah, so this is the problem sometimes with doing online classes. There's all kinds of technical problems that come up. Okay, mic test. Can you hear me now, Kolisi? Or still no sound? Okay, good. All right. So Kolisi can hear. Okay, so I'll go back a little bit. So a resolution of forces is when we take one force. Okay, for example, in this picture, you have a pulling force that's being pulled in a diagonal direction, and we divide it into two parts. So we divide it into a horizontal force and a vertical force. So it's like the opposite of resultant force. Resultant force, we take two or more forces and combine it into one force and one direction. Resolution of force, we divide one force into two directions, two different directions, usually vertical and horizontal. So the formula actually is not hard, and the way we do it is actually not hard. It's just that sometimes the questions can get a little bit confusing. So steps to resolve a force. So basically it's only 3 steps. Okay? You draw a horizontal component. So when you're given a question, you're going to usually the question will just give you the force and the direction and the angle. For example, a question might look something like this. So you'll be given a force and you'll be given an angle. So I'm just going to put theta as the angle. So the first thing you want to do when you have a question like this, so the first thing you want to do is to draw the horizontal part or the horizontal component. So your textbook calls it the X being x-axis, so horizontal. I've also seen other sources that you also use the word F uh, horizontal. They just put horizontal. Either one is fine. It doesn't really matter. But your textbook just uses fx lah for x-axis. So you draw the horizontal component, then you draw the vertical component. And so vertical component. So F y, or we can also say F vert for vertical. So you begin with just one line, and then you add the other two lines, and this should be 90 degrees. Okay, for what we are learning is we will only be learning questions that involve perpendicular angles for the horizontal and vertical force. Then the next step is calculate the magnitude of the component. So once you have your vertical and horizontal, then all that's left for you to do is to calculate everything. Okay, so the formula that's given in your textbooks is to find fx. To find fx, you just type in F, so force, cos, and then theta. And for Fy, you use sin. Fy is F sin theta. So why is it F sin why is it Fx equals F cos theta, and why is Fy equals F sin theta? Is because of how trigonometry works. So let me just show you where the formula comes from. I find that when you understand where the formula comes from, it's easier for you to figure out how to use it. So where does the formula come from? So let me go back. So we have Fx, Fy. So we know that sin, okay, the law of SOHCAHTOA, right? SOHCAHTOA, I'm sure you've all learned it. So sin is opposite over hypotenuse. Opposite over hypotenuse. I may have spelled that wrong, but never mind. And cos, what's cos? Cos is adjacent. Adjacent over hypotenuse. You've learned that already in the past, right? So if we look at the picture, the sin for this one, okay, opposite. What is the opposite of this angle here? It's here, which we know is equal to Fy. So sin is Fy over your hypotenuse is F, because this line here represents F. So once you understand this part, then you can just rearrange it. You can just rearrange it to make it F equals, sorry, Fy. You can just rearrange it. So F, you just move it here. So Fy equals F sin. You can find this explanation actually in your textbook as well, but it doesn't go step by step into explaining it. Okay, same thing with, it's the same idea with cos. Let me just, so cos, because adjacent, so adjacent of hypotenuse. So For your cos for this one, your adjacent is this line here, fx. Your hypotenuse is again f. And once again, you can just rearrange so that f goes up here. So fx equals f cos. That is where the formula comes from. That's how you get the original formula. So now to make it easy, you can just memorize this. There's nothing wrong with memorize this as long as you understand where it comes from and why is it fx equals cos f cos theta and why does fy equals f sin theta. Now, the other thing that you need to be careful when you're answering questions is you have to look at which angle it is given. If the angle is this one, so if you get, sometimes the question, instead of giving you this angle, it'll give you this angle instead. If you get that, then you have to, then what you do, either you find this angle, which is fine, or you kasih to balik saja lah. In that case, fx, this time fx will be using sin, and fy will be the one using cos. Because now we've flipped the sides that we are using. Or if you don't want to do that, then just use, then just find the angle here lah, just minus 90 and you'll be able to find it. So that's where the formula comes from. That's how you get the formula itself. Now tan, I haven't found any questions that uses tan yet, so that's probably not going to come out. I'm sure you'd be able to if you really want to, but the textbook focuses on cos and sin, so that's what we'll be using. So here's an example in your textbook. So if you have the textbook, you can look for example number 1. I forgot what page is this, but you look for 2.8 and topic 2.8 and look for the first example that's given for the question. So let's read the question first. Well, let me take out my face is blocking the. Let me just move my face first. There you go. So let me read that out and you can read that along with me. Figure 1.19 shows a wooden block being pulled by force T. So the main force that we're talking about is T. That inclines at an angle of 30 degrees above the horizontal surface. Table 1.5 shows the magnitudes of forces acting on the block. So it shows that T is worth 36 newtons, weight equals 24 newtons, normal reaction is 6 newtons, and frictional force is 20 newtons. So one thing that you have to be careful, there's a lot of information here, and so it's really easy to get confused to start thinking, okay, which information am I supposed to use? That's one of the challenges of I should say challenges of physics. Sometimes they give you a lot of information, but you actually don't need to use everything yet. So the first question is calculate the magnitudes of the horizontal and vertical components of the pull T. So let's do that right now. You can try this along. The answer is in your textbook, so you don't actually need me to show you the answer. But what I wanted to show you is how you do it step by step. Okay, so you have the pull T. And we know that T equals 36. Okay, just like it's given in the question. Now, what about the others? What about the other ways? The weight is 24 newtons. The normal reaction is 6 newtons. The frictional force is 20 newtons. Do I need to take that into account? No, you do not. Why? You do not need to take these other things into account yet, because you only need to resolve the force. You're not looking for resultant force yet. You're just looking for the resolution of just one force, which is T. So since you're only worrying about T, then just worry about T and don't worry about the others yet. That will be for question B and C. So, okay, that's not, okay, that's a mistake. So let me go back here. So what can you do? So T. So we'll just follow the steps that we did just now. So first we have the horizontal. So we'll call it Fx. You can also call it Tx if you want. It doesn't really matter. And we have the vertical component, which is Fy, or F vertical, or Ty. Doesn't really matter. It doesn't really matter when you're doing the calculations. It doesn't really, it's not so important what letter you use. Of course, there's a standard letter to use because it helps us. It helps to avoid confusion, but it doesn't really matter that much. Okay, and then the angle is given to be 30 degrees. So you have a 30-degree angle here. Okay, and that's all you need. That's all you need now to find Fx and Fy. So back to the formula just now. We know that Fx equals F, in this case T, F cos 30. So Fx equals 36 cos 30. And if you have your calculators, you can go ahead and calculate that. And let me just open my calculator as well. I actually did this question already, but I forgot. I forgot, and I don't have my textbook open. So, not this. There we go. So 36 cos 30. Okay, so my answer is, on my calculator, it says 31.18. Okay, I think the textbook also says that, 31.18. Can someone check my answer? Someone could check the textbook or use a calculator to check. It should be 31.18. Okay. One thing that you need to make sure if you're using your scientific calculator, I made this mistake the other day. Make sure that your calculator is set to, you can't really see it, but make sure your calculator is set to degree and not radian. Because if you change your calculator to radian, sometimes you press the wrong button and you set your calculator to radian mode, you'll get a completely different answer. You should be using degree. So anyway, 36.18. So that's Fx. So let's write it down. So Fx equals 31.18. It's not, it shouldn't be degrees. So 36 newtons, and in here is 31.18 newtons. So in this direction. Radian for admets, perhaps. Radian is when you're calculating. I forgot what topic it was. It's been a while, but yeah, it's in admets. Okay. So now we look for Fy. So same thing. Fy equals sin. Sorry, 36 sin 30. And so you can calculate once again. So 36 sin 30. And my calculator says 18. And so you have 36 newtons in direction of T. Fx is 31.18 newtons, and your vertical force is 18 newtons. So that's how you calculate the vertical and horizontal force. Now sometimes you have to read the question carefully, because there are questions, or there are questions that when you read it, you're not so sure where is the horizontal and where is vertical until you read carefully. So let me continue with this one. So let's go back here. So now you've answered the first question, which is to calculate the vertical and the horizontal component. So now the second question is B. Determine the magnitude and direction of the resultant force. So now, question B, this is where we apply what we learned last lesson. And this is also where we now take into consideration the other numbers that we have, like the weight, the normal reaction, the frictional reaction, and whatnot. So let me just write that down first. So the information that we already have is we have the horizontal pull and we have the vertical pull of Fx and Fy. Okay, so now determine the magnitude of the resultant force acting on the block. So we have several ones working here. We have weight which is going down at 24. We have frictional force which is going this way in 20 newtons. We have normal reaction, which is 6 newtons. And yes, that's the only one given. So we need to calculate vertical and horizontal separately. That's what we usually do. So first, let's calculate the vertical. Okay, so for vertical, up is positive, down is usually negative. So what do we have here? So first we have the weight. So we have, let's call vertical force. So the weight of the block itself is going down at negative 24. Then the normal reaction is going up, so plus 6, and Fy, which we calculated earlier, is also going up at 18. So you get your resultant force of 0. Meaning to say the block is neither going up or down. So resultant force in other words, there's no result, it's 0 there. We just have to look now at the horizontal. So we just calculated vertical, horizontal. Okay, so horizontal, what do we have? First we have the one Fx, which we calculated earlier at positive 31.18. Your textbooks, I noticed when you need to simplify a long number, it usually goes up to 2 decimal numbers. So I would just follow that. Your answer will not be that far if you round off to 1 or 3. But since the textbook does 2, then I'd follow that. Okay, and going to the left, we have 20 newtons. So minus. Right we take as positive, and left we take as negative. And so we end up with a total of 11.18 newtons. So your final resultant force is 11.18 newtons to the right. That's just a little bit of review of what we learned in topic 1.1. Now the final question is now has to do with acceleration. So actually, only question A is really talking about resolution of force. Question B is talking about resultant force, and question C is stuff that you've already learned in the past. What is the acceleration of the block if the mass is 2.5 kilograms? So, what formula do we use? If it's acceleration, anyone remembers? Okay, so F equals mass times acceleration, right? So F being force, mass being, well, mass is mass and acceleration. So what I like to do is I'll find the formula first. Actually, let me write down first the information that you need. So mass is, we know that mass is 2.4, and it's already, and we also know that the force is 11, or let's just say F equals 11.18. Now, what I usually do is I write down the formula first, just so that I can see clearly what information I need. Then what I do is I rearrange the formula to find whatever I need. So for example, the question is asking for acceleration. So I just need to rearrange the formula so that acceleration is the one that I end up with. And so what do I need to do for this question? For in this case, F goes down, so we divide force by mass. That's right, right? Yeah, that's right. And so once I have this, then I just put in the numbers. So acceleration is equals force 11 point over 2.4. So 11.18. I did this yesterday, but so 4.66 meters per. So an acceleration of 4.66 meters per second. Someone double check my answer. I think that's correct, but I forgot. If you have your textbook, if you have the textbook, you can find the answer there. And so it's really important when we're using formulas. By the way, it's really some students, they like to go from here straight to here, and if you can do that and not make mistakes, that's fine. But if not, then it's better to do step by step solving, so that you can find whatever component of the question that you need. Okay, any questions so far about how we've solved the questions? Okay, Davey has no questions. How about the rest of you? Okay, if that's the case, we can go on to example 2. Now for example 2, give me a moment to bring up example 2. Because I completely forgot to paste a picture of example 2 in the slide. But that's fine because I also have the textbook in my computer anyway. So let me just bring up the correct question. Let me just change the slides first to the textbooks. Okay. So let me just, because I want to do the second example, because the second example is a good example of a question that needs to be read carefully. There you go. So yeah, the answer is all here. Okay, so I got the correct answer. Alright, so here's example 2. Let me zoom that a little bit. So example number 2 says, figure 1.20 shows the free body diagram of a block sliding down a smooth inclined plane. And then it shows you a picture here of that block. So the block is showing a weight going down of 24 newtons. There is an angle of 60 degrees, and there is a normal reaction of 12 newtons going in that direction. So the question here is, sketch the component of the weight of the block parallel to the inclined plane and the component of the weight of the block perpendicular to the inclined plane. So that can get a little bit confusing. So let's go through it one by one. So in this kind of question, since you have to make sure where is horizontal. Because if you're not careful, you might end up with the wrong thing. So this is the picture. This is a simplification of the picture. And we have the block, right? The component of the weight parallel to the inclined plane. Parallel to the inclined plane meaning to say in this direction. And component of the block perpendicular to the inclined plane meaning to say in this direction. Since it's the block, so the block is going this way. So in this direction. So this is where you need to be careful, because this is your horizontal and your vertical. It doesn't actually look horizontal, right? Unless you turn it to make it horizontal. So that's the resolution that we need to do. Right, so you just need to sketch it. You don't need to calculate it yet. And then the next thing you have to do is determine the resultant force acting on the block. And then you have to determine the acceleration of the block if the mass is 2.4. So similar concept of what you need to do. Let me just show that again. So for this question, you really have to read carefully. It took me a few times as well of reading just to make sure that I got the correct sketch. And once you got the correct sketch, you determine the resultant force and calculate the acceleration of the force. So since the textbook has the answer, so just like what I said, you have to draw it properly lah. So you have Wx and Wy, and you form a triangle. And it's already given 60 degrees. Now, the only thing that's I would say a little bit, you have to be a little bit careful with is this. You have for x, instead of using cos, it uses sin. Okay, because the angle is on this, instead of being instead of the angle being adjacent to the x, the angle is adjacent to the y. So sin would be the correct one to use. So that's just something to take note lah. So 24 sin 60 equals 20.78 newtons, and the other one 20 cos 60, 12 newtons. So resultant forces perpendicular to the inclined plane is 0, and resultant force on the block is 20.78 newtons. Okay, calculation of the acceleration is exactly the same. Force equals mass times acceleration. Acceleration is F divided by mass. So 20.78 8.78 divided by 2.4 equals 8.66. So very much, it's pretty much the same as the last question. The only thing that's a little bit confusing is the first part, right? Trying to find the correct angle for everything. All right, so formative practice 1.2. So now what I want you to do, we have plenty of time. We actually have 40 minutes left in this class period. So I want you to do formative practice 1.2 and so question 1, you have to resolve the vertical and horizontal. So look for the vertical and horizontal and be careful where the angle is. Okay, based on where the angle is, that will be the deciding factor on whether you're using sin or cos. So you have to be careful with that. And number 2 is same thing, resolve the pushing force into its vertical and horizontal component. And B, state the function of the horizontal and vertical component. So the reason why we divide a force into 2 parts is that usually the force is doing 2 things at once. So what's the downward force doing and what's the forward force doing? So you just need to state it very simply lah. Okay, so question 1 and 2, why don't you go ahead and try that? And I'll be trying to solve that as well. So let's do it step by step. All right. So let's look at the question and let's do it step by step. So you have your force, 70 newtons. So we write down our horizontal force, Fx, and our vertical force, Fy. So we just use the same formula that we studied just now. Okay, so Fx equals 70. Let me just write out the full formula. So F cos 70. Sorry, I forgot to write down the angle. The angle is 42. 42. So 70 cos 42. And your answer is? What's your answer? $52.02. Is that your answer? Did everyone get the same answer? Okay, I see a couple of people yes. So if you didn't get the same answer, one thing you could do is just to check your calculator if it's in degree or in radian mode. But if everything is working okay, then you should have the correct answer lah. Okay, Fy same thing. F sin 42, and so 70 sin 42. So 70 sin 42, 46.84 newtons. Everyone got the same answer for that one as well? For the vertical, for the vertical force. I think everyone got the same answer. Yes, okay. Yes, yeah. So if you got the first question correct, the second answer is probably going to be correct as well. Okay, so how about question B? How many people have done question B? I prefer to look at a triangle that had just been formed and use trigonometry to use the magnitude. There's nothing wrong with that. You can do that. You can absolutely do that. Because this is basically trigonometry. We're just basically calculating triangles. is what we're doing. So you can do it like that. There's nothing wrong with doing it like that. If it helps you, okay, let's talk about that. So for some people, it might be easier to do it like what Henry does. So I'm not sure how exactly Henry does it, but if what I'm understanding what Henry is saying, he likes to make a triangle first. So basically, 70, this is F, F, Y, and let me put it like this. So you have a sort of triangle like this, where this is 70, F, and then you have uh, your X and F, Y. And you have your angle here, which is 42. Here is 90. And here is whatever is left is that angle. Right? So that means, so you can use trigonometry to try and figure it out. So you can use other angles. That's fine. There's nothing wrong with that. So you could calculate it like what I showed earlier. So for example, you might want to say sin 42 equals, so 42, so opposite is Fy over F. You're still basically doing the same thing. And so Fy equals F sin 42, and then you get your answer. You'll still get the same answer eventually. Alright, so yeah, there's nothing wrong with trying to find another way to do it in physics, as long as you know what you're doing lah. So this one basically is all trigonometry. Okay, let's go ahead with question B. Go ahead and do question B, and let me know when you're done. 5 people done. So if it's 5 people done, that's everyone. All right, let's look at it. So we have, well, let me just write it down. So we have your force, which is 90 newtons. And then we have our Fx and Fy. And this is the angle given, which is stated to be at 64. So if we look at the question, same formula still applies. Yes, because we'd still be using sin. We'd still be using cos adjacent over hypotenuse. So same formula, Fx equals F cos 64, and Fy we're still using F sin 64. So still same thing. So 90. So 90 cos 64 equals 39.45 newtons, and 90 sin 64 equals 80.89. Is that the same answer that everyone got? Yes, sir. Okay, so Kyle has the same answer as me. Yep, okay, good. So we're getting it. You could even actually, if you could even do, if you really wanted to, you find fx using cos, and then you find fy using Pythagoras. You could even do that if you really wanted to, but I would say it's faster to use sin and cos lah, if you really wanted to. Only two people got the same? How about the rest of you? You got something else? No? Okay, so you got the same answer. Say so. Okay. Okay. All right. So last example. So go ahead and do question number 2. So there's part A and part B. It's basically the same thing. So same thing. Write down your answers and then go ahead and tell me when you're done. Okay, for this one, be careful with the angle that you use. Be careful with which trigonometry function you're using, whether using sin or cos. All right, let's go. All of you are done. Let's go into the question. So I went ahead and drew it. So we have 90 as our force. We have Fy, our vertical component, and we have an angle of 60 degrees between Fy and the force, or the F. Let me just write down F. And we have Fx. So, listen carefully. So this time, Fx, okay, we are not going to be using cos. Okay, why we are not going to be using cos? Remember, cos equals adjacent over hypotenuse, right? But for the angle, Fx is not adjacent to this one. Fx is opposite. So instead of cos, we'll be using sin. So Fx equals sin, 90 sin 60. So if you use cos instead of sin, then automatically salah lah jawapan kamu. Alright, so 90 sin 60 is 77.94. And Fy, so this time Fy is the one that we use cos, because Fy is the one that's adjacent. Remember, ka. So katoa. Cos equals adjacent over hypotenuse. So 90 cos 60. And our final answer is 90 cos 60 equals 45. So 45 degrees. So did everyone get the same answer as me? Yes, okay, good. All right, so you didn't miss out on using the correct formula. Okay, good. Okay, Henry saying that he really likes trigonometric function. Yeah, it's an interesting subject. It can get complicated, but it's a lot of fun. I agree with you. I prefer triangles, calculating triangles to other shapes. All right. Now, question B. Question B, we can just state it together. State the function of the horizontal component. So meaning to say Fx. So what is the function of the horizontal what does the horizontal force do to the lawnmower? I mean, it's obvious, but what does it do? Henry says he likes admaths. Well, I'm glad you like admaths. Okay, so Davey says overcome frictional force. Okay, yes, that's fine. What else? What happens to the lawnmower? To push the lawnmower. Yes, exactly. It pushes the lawnmower forward. It propels the lawnmower to the right. Yeah, you can say that. So that's the point of the horizontal force. And what about the vertical force? So what does Fy do? The downward force Fy do to the lawnmower? Or what is the point of that force? Apa fungsi dia? Yeah, it pushes it down, prevents it from flying. Yeah, you could say it stabilizes the lawnmower. It pushes the lawnmower down. It pushes the blades into the grass. So far, prevents it from flying. For this one, is really as long as your answer makes sense, it's pretty much correct. For this one, this is not a super like scientific question or anything. So as long as your answer is more or less correct, I'm sure they'll accept it.